have the Mamarubot SX4 Core XY printer from Tiny Machines. There's been a bit of activity lately with the dual Z-axis as far as doing the auto alignment using G34 to have the BL Touch probe come and check both sides of the bed to automatically balance your gantry. This is important on machines like this, as most of the time when the power is cut off, the bed tends to drop down very unevenly. It can do this with just a slight amount of pressure and can wobble back and forth. Now in many cases this is actually a sign of very good alignment when it moves this freely, so the effect of them being able to move this easily is actually desirable and talks to a good build quality and good alignment, and that you're not over constrained. However, that does put your bed leveling way out of whack and requires you to either balance the gantry every time or to go through and redo your probing routines before every print. However, this can be quite undesirable as it takes a large amount of time. However, they do have the fifth driver soldered onto this board, so it's very easy at that point to take the second Z motor and configure it to run independently and allow the BL Touch probe that comes stock to be able to check for and compensate for that deviation automatically. All that you need in order to install this modification is a single cable with a 6-pin to 4-pin header. This is the same stepper cable that you'd use just about anywhere else. And you can see the last socket here is wide open. The only problem is there's no heat sink on it. You don't require a heat sink on the Z as it's one of your lighter duty motors. However, it is recommended to get one of the small heat sinks off of Amazon or anywhere else to install on here to keep the driver from overheating. However, all you need to do is plug this cable right into the open port and feed it out through the bottom of the box with the rest of your cables. From there, simply unplug the existing Z stepper that's on the left hand side from the control box. And plug your new wire right in. Assuming that you've already pulled in the GitHub repository for the Mamarubot SX4 Tiny Machines Edition, I've opened up VS Code and Platform IO as covered in a separate video. The option that we're primarily concerned with today is dual Z here. In order to enable any option, simply remove the 2 slashes in front of it. To work with the machine that I've currently got set up here, I'm also going to enable the full graphics LCD as well as unified bed leveling, as I prefer that much over bilinear. From here you can click on the Platform IO anthead icon and then upload and monitor, and it'll begin the flashing process to the machine. While this is flashing, we can take a look at the couple other options that you may want to look at under Configuration Advanced. Here you can change the actual G34 max grade as well as the stepper alignment amplification. The max grade is the maximum amount of deviation that it's allowed to correct for. And this is useful to prevent it from binding up on your Z-screws should it come drastically out of balance and causing any damage to the machine if the steppers can't physically move or if the probe can't physically reach the bed. You can bring this up a little bit higher of a percentage than this safely on these machines, but until you're comfortable with what it's actually doing, I would leave it at the default for now. The stepper amplification is the amount of additional compensation that it's going to do over what it actually detects, and if you're not getting enough compensation and want to try and reduce the number of cycles you're running, you can try to tweak this parameter. The alignment accuracy is the point at which it would stop iterating. If you sent a G34i10 to allow it to run through 10 iterations, for example, when it achieves this accuracy, it's going to abort, even if it's only done 2 or 3 iterations. From there, our machine is successfully flashed and is now online. You can run through a test if you'd like with G28 to home the machine. And once that's complete, follow up with the G34. And now you can see that with the single run of the default count of iterations, we've reduced our deviation on the X gantry from more than 2 millimeters down to 0.1 millimeters across the width of the bed. And there you have it. The automatic bed alignment routine has been completed, which is the actual true form of automatic bed leveling, so to speak, instead of the bed compensation techniques that are typically employed and called automatic bed leveling. If you have any questions on this, feel free to give us a message or drop a comment in the notes below, or contact us on the Facebook group. If you purchased your machine through Tiny Machines, you can contact them for a discounted cable to be sent out to you, or when you're purchasing a new machine through them, request that the additional Z cable be set up and pre-installed.